Okay, let's look at question number 13, part A. So this is the matrices question. So we are given A, B are positive integers where A is greater than B and capital A is this matrix. And we need to find A, B so that A squared is equal to this, right? So then let's first find A squared. So we have to multiply A with A again. So now matrix multiplication, right? So let's create the first term. A into A, B into 7. So add them, A squared plus 7B. Then the second term in the first row, A into B, B into A plus B. So that gives you 2AB plus B squared. Right, now let's move on to the second row. 7 into A, 7 into A plus B, which gives you 14A plus 7B. Then last term, 7 into B, A plus B into A plus B. So 7B A plus B square. Right. So then A squared is what? 23, 16, 56, 39. So this is going to be equal to the matrix we just found. A squared plus 7B, 2AB plus B squared, 14A plus 7B, 7B plus A plus B whole thing squared. Right. So if two matrices are equal, corresponding elements are equal. So we'll create two equations. Two unknowns mean we only need two. No? So create the two easiest. I will compare the first terms on both sides. 23 is equal to A squared plus 7B. Then next one, use the easiest one we can create. I will compare these two. Second row, first element. So 56 is equal to 14A plus 7B. So then I can do what? 2 minus, no, 1 minus 2. No, 1 minus 2 to cancel 7B, and I will get A squared minus 14A is equal to minus 33, or A squared minus 14A plus 33 is equal to 0. So this is a quadratic. So solve the quadratic by factoring or by using quadratic formula. I will do factoring because this is easy to factor. You get A minus 11 into A minus 3 equals 0. So A equals 3 or A equals 11. Right, now using one of the equations, find the corresponding B values. So you have A equals 3, then let me use first equation. So A squared plus 7B. So that means 9 plus 7B has to be equal to 23. So that means 7B is equal to 14, or B is equal to 2. Right. Then we'll check A equals 11. So A squared is 121 plus 7B equals 23. So 7B is equal to minus 98. So B is equal to minus 14. Right. What is given to us? A, B are positive integers. So this can't be an answer. So this set is not an answer. Answer is A equals 3 and B equals 2. So that's the answer for the first part. So then we'll write down that matrix. So now the matrix has what form? A is 3, B is 2. So 3, 2, 7 and A plus B. 7 and 5. Right. So that is A. Right. So first part is done. Now let's look at the second part of the question. Now, right. We have to find K and H so that this is true. For the AB values we found, so we for the AB values we found, we have a matrix A. we use that matrix. So we have to find k and h so that this statement is true. A squared plus ki is equal to ha. So right, we have to find a k value and h value that will make this equation true. So let's use what we know. A squared is what? 23, 16, 56, 39. Ki means identity matrix. No? So k into I gives you k0, 0, k. Ha means each term has to be multiplied by h. So 3h, 2h, 7h, 5h, right? So right hand side, let me add the two matrices together. So 23 plus k, 16, 56, 39 plus k. So then what do we have? 3h, 2h, 7h, 5h. Right. So these two matrices are equal. No? So then we can compare terms and get the answer. So I will compare 16 to 2h. That's the easiest thing to do. No? 16 to 2h gives me h equals 8. Then compare something with k. So 23 plus k has to be equal to 3h. So 23 plus k has to be equal to 24 or 3h. So 3h is 24. No? H is 8. So 23 plus k equals 24. Then k equals 1. Right. So then what the statement is what? A squared plus I is equal to 8a. Right. That one is done. Then hence find A inverse. Right. We have to use that expression to find A inverse. Right. Okay. So then what can you do? Multiply each term by A inverse. We have to create A inverse. No? So A squared is A into A. Again multiply by A inverse from the right hand side. So I into A inverse. 8 into A inverse. So A times A inverse is identity. So these ones you can replace with identity. Identity into A inverse is A inverse. So what do we have? A into I is A plus A inverse equals 8I. So then A inverse is equal to what? 8 times identity minus matrix A. So 8I is what? 8008 minus A is what? A matrix we found 3275. 3275. Right. So then what is A inverse? A inverse is 5 minus 2 minus 7, 3. Right. So that is A inverse. Right. So that one is done. Then let's see what's the next part. If B is given by this, show that B is equal to that. Okay. So let's write B A transpose. Simple A is 3, no? So B 3 times A transpose plus B into A inverse. B is 2, so 2A inverse plus 2A inverse, right? So then A transpose is what? Okay, transpose of this one. So A transpose is 3275. So 3725. 3725. 2, 5 plus 2 into A inverse, which we found A inverse is what? 5 minus 2 minus 7, 3. Right. So then this becomes 9, 21, 6, 15. When we multiply the second matrix by 2, you get 10 minus 4 minus 14 plus 6. So 19, 17 minus 8, 21. Right. Let's see if that is what we want to show. Yes, 19, 17 minus 8, 21. Right. So that is the matrix part of the question. Right. Then we'll do 13 part B and C, the complex number part.